Recalling ratios and percentages. Ratio means comparing two quantities. There are two types of fruits in a basket. It has 10 apples and 15 mangoes. The ratio of the number of apples to the number of mangoes is equal to 10:15. Comparison can be done by using fractions as 10/15, that is also equal to 2/3. The number of apples is 2/3 times the number of mangoes. The ratio is 2:3. The number of mangoes to the number of apples is equal to 15/10, which is equal to 3/2. The number of mangoes is 3/2 times the number of apples. Here, the ratio is 3:2. Comparison can also be done by using percentages. The total number of fruits are 10 apples plus 15 mangoes, that is, 25 fruits. Percentage of apples is equal to 10/25 into 4/4, which is equal to 40/100. 40%. Therefore, the percentage of apples is 40%. Percentage of apples plus percentage of mangoes is 100%. Therefore, the percentage of mangoes is 100 minus 40, that is 60%. Out of 25 fruits, the number of apples is 10. Out of 100 fruits, the number of apples is 10/25 into 100. That is equal to 40. Problem. Convert the ratio 2:3 to percentages. Solution. 2:3 is equal to 2/3, which equals 2/3 into 100/100, which is equal to 66 2/3%. Problem. Find the ratio of the following. A. 30 minutes to 1.5 hours. B. 500 milliliters to 2 liters. Solution. A. 30 minutes to 1.5 hours. Since the units are different, change 1.5 hours to minutes. 1.5 hours is equal to 1.5 into 60 minutes, which is equal to 90 minutes. Therefore, the ratio of 30 minutes to 1.5 hours is 30/90. HCF of 30,90 is 30. 30 divided by 30, whole divided by 90 divided by 30. It is equal to 1/3, or 1:3. Therefore, the ratio of 30 minutes to 1.5 hours is 1:3. B. 500 milliliters to 2 liters. 2 liters is equal to 2 into 1000 ml, which is equal to 2000 ml. Therefore, the ratio of 500 ml to 2 liters is equal to 500/2000. HCF of 500, 2000 is 500. 500 divided by 500, whole divided by 2000, divided by 500. It is equal to 1 by 4, or 1:4. Therefore, the ratio of 500 ml to 2 liters is 1:4. Problem. 72% of 25 students are good in mathematics. How many are not good in mathematics? Solution. Total number of students is equal to 25. Students good in mathematics is equal to 72%. Therefore, students who are not good in mathematics is equal to 100% minus 72%, which equals to 28%. Number of students who are not good in mathematics can be found as 28% of 25 students. It is equal to 28 by 100 into 25, which is equal to 7. Therefore, the number of students who are not good in mathematics is equal to 7. Finding the increase or decrease percentage. In our everyday life, we often come across information like, a man received a 10% raise in salary. His present salary is Rs 55,000. What is his new salary? 10% of 55,000 is equal to 10 by 100 into 55,000, which equals to 5,500. New salary is equal to old salary plus increase, which equals to 55,000 plus 5,500. It is equal to 60,500. New price is equal to old price plus increase. Problem. Suppose given that his old salary is Rs 55,000, and a new salary is Rs 60,500. Find the percentage increase. Solution. Increase is equal to new salary minus old salary. That is equal to 60,500 minus 55,000, that is 5,500. Increase percentage is equal to 5,500 by 55,000 into 100%, which is equal to 10%. Therefore, increase percent is equal to increase by old salary into 100%. Problem. In order to increase the sale of televisions, a television company decreased its price by 25%. If its actual price is Rs 25,000, find its new price. Solution. 25% of 25,000 is equal to 25 by 100 into 25,000. So, the reduction is equal to Rs 6,250. New price is equal to old price minus reduction. We get 25,000 minus 6,250. So, the new price is equal to Rs 18,750. Problem. Suppose given that old price is Rs 25,000, and the new price is Rs 18,750. Find its decrease percent. Solution. Decrease is equal to 25,000 minus 18,750, which equals to 6,250. Decrease percent is equal to 6,250 divided by 25,000 into 100%. It is equal to 25%, which can be calculated as 25%. Therefore, decrease percent is equal to decrease by old price into 100%. Finding discounts. Discount is a reduction given on the marked price of the article. Discounts are generally given to attract customers to buy, or to promote sales of goods. Discount can be calculated by subtracting the selling price from its marked price. Problem. During a sale, a shop offered a discount of 20% on the marked prices of all items. What would a customer have to pay for a pair of jeans marked as rupees 1,500 and two shirts marked rupees 800 each? Solution. Marked price of a pair of jeans is equal to rupees 1,500. Discount is equal to 20% of rupees 1,500, that is, equal to rupees 300. Sales price is equal to marked price minus discount. That is, rupees 1,500 minus 300. So, the sales price for a pair of jeans is equal to rupees 1,200. Marked price of two shirts is equal to 800 into 2, that is rupees 1,600. Discount is equal to 20% of 1,600, that is, rupees 320. Sales price is equal to marked price minus discount, that is, 1,600 minus 320. So, sales price for two shirts is equal to rupees 1,280. Therefore, total payment to be made by customer is equal to rupees 1,200 plus 1,280, that is equal to rupees 2,480. Estimation in percentages. Your bill in a store is rupees 576.70, and the shopkeeper gives a discount of 10%. How would you estimate the amount to be paid? Solution. Round off the bill to the nearest tens. Here, rupees 576.70 is rounded off to 580. Find the amount of discount. 10% of 580 is rupees 58. Reduce the bill amount by discount amount rounded off 58 to 60. 580 minus 60 equals to 520. Therefore, the estimated amount to be paid is rupees 520. Problem. Try to estimate 20% of the same bill amount, rupees 576.70. Solution. Round off the bill to the nearest tens. That is, 576.70 to 580. 20% of rupees 580 is equal to 20 by 100 into 580, which is equal to rupees 116. Therefore, an estimate of 20% of rupees 576.70 is equal to rupees 116. Prices related to buying and selling, profit or loss. Let us first understand various terms related to an article bought and sold by a shopkeeper. Cost price. The buying price of any item is known as its cost price, denoted as CP. Selling price. The price at which an item is sold is called its selling price, denoted as SP. Profit. If selling price is greater than cost price, then we make a profit. Profit is equal to selling price minus cost price. Loss. If cost price is greater than selling price, then we make a loss. Loss is equal to cost price minus selling price. Profit, or loss percent. Profit or loss is always calculated on the cost price. Profit percent is equal to profit by cost price into 100%. lost percent is equal to, loss by, cost price into 100%. Overall gain. Overall gain is given as, combined selling price minus combined cost price. Overall loss. Overall loss is given as, combined cost price minus combined selling price. Overhead charges. When an article is bought, some additional expenses, like labor charges, transportation charges, etc., are made while buying or before selling it. These are called overhead charges. These expenses need to be included in cost price. Problems on profit and loss. Problem. A shopkeeper buys 80 articles for rupees 2,400 and sells them for a profit of 16%. Find the selling price of one particle. Solution. Given, cost price of 80 articles is equal to rupees 2,400. Profit is equal to 16% of rupees 2,400. That is, 16 by 100 into 2,400, which is equal to 384. Profit is equal to rupees 384. As we know, profit is equal to selling price minus cost price. Selling price of 80 articles is equal to cost price plus profit, which is equal to rupees 2,400 plus rupees 384, which is equal to 2,784. Selling price of 80 articles is equal to rupees 2,784. Therefore, the selling price of one article is equal to 2,784 divided by 80, which is equal to 34.80. That is, rupees 34.80. Problem. A DVD player and TV were bought for rupees 8,000 each. The shopkeeper made a loss of 4% on the DVD, and profit of 8% on the TV. Find the gain, or loss percent, on the whole transaction. Solution. Given, combined cost price is equal to, rupees 8,000 plus rupees 8,000, is equal to rupees 16,000. Loss of 4% on DVD can be calculated as 4% of rupees 8,000. That is, 4 by 100 into 8,000, which is equal to rupees 320. We know that loss is equal to cost price minus selling price. Therefore, selling price of DVD is equal to cost price of DVD minus loss, which is equal to 8,000 minus 320, which is equal to 7,680. Profit of 8% on TV is equal to 8 by 100 into 8,000, which is equal to rupees 640. Since profit is equal to selling price minus cost price, selling price of TV is equal to profit plus cost price, which is equal to 640 plus 8,000. So, the selling price of TV is equal to 8,640. Gain of whole transaction can be calculated as combined selling price minus combined cost price, which equals to rupees 16,320 minus rupees 16,000, which is equal to rupees 320. Gain percent is given as gain by cost price into 100%. Therefore, gain percent can be given as 320 by 16,000 into 100%, which is equal to 2%. Therefore, gain percent on whole transaction is equal to 2%. Compound interest. Have you ever come across statements like saving account with interest at 8% per annum, or 2-year interest for fixed deposit in the bank? But what is this interest? Interest is the extra money paid by institutions like banks or post offices on money which is deposited with them. Interest is also paid by people when they borrow money. Interest is generally given in person for a period of 1 year. Principal. The money deposited or borrowed is called the principal. Simple interest. Simple interest is defined as the fixed rate of interest charged for a fixed period of time, or it is the interest calculated only on the initial amount that is invested. Formula for simple interest. Let principal is equal to P. Rate of interest per year is equal to R%. And the number of years is equal to T. Then, simple interest is calculated as SI equals to principal into rate of interest into time by 100. Amount A is equal to principal P plus interest I. Problem. Find interest and amount to be paid on rupees 15,000 at 5% per annum after 2 years. Solution. Given principal P is equal to rupees 15,000, rate of interest R is equal to 5, and the number of years is equal to 2. Here, interest is nothing but simple interest. Interest is equal to PTR by 100. That is equal to 15,000 into 2 into 5 by 100, which is equal to 1,500. Therefore, interest is equal to rupees 1,500. Amount A is equal to principal plus interest, that is 15,000 plus 1,500, which is 16,500. Hence, the amount is equal to rupees 16,500. Compound interest. Part 2. The interest, calculated on the amount of the previous year, is known as interest compounded, or compound interest, commonly denoted as CI. Let us understand with examples how we can calculate Compound interest. Example. Kajal borrowed Rs 26,400 from a bank to buy a scooter at a rate of 15% per annum, compounded yearly. Find the compound interest and the amount she has to pay at the end of 2 years. Solution. Let us follow these steps. First, find the simple interest for 1 year. P1 is equal to 26,400. R1 is equal to 15. T is equal to 1. So, simple interest, SI1, is equal to 26,400 into 1, into 15, divided by 100, which can be calculated as Rs 3,960. SI1 is equal to 3,960. Second. Now, find the amount which will be paid or received. Amount becomes principal for next year. Amount at the end of first year, that is A1, is equal to the principal of the first year, T1, plus simple interest. It is equal to 26,400 plus 3,960, which is equal to Rs 30,360. This becomes the principal amount for the second year. Third. Again, find the interest on this sum for another year. Principal, P2, is equal to Rs 30,360. Simple interest is 15% for second year, that is equal to 30,360 into 15 by 100. Simple interest is equal to Rs 4,554. Fourth, find the amount which has to be paid or received at the end of second year. Amount at the end of second year is equal to P2 plus SI2. It is equal to Rs 30,360 plus 4,554. Which is Rs 34,914. Therefore, amount she has to pay at the end of second year is Rs 34,914. Compound interest is equal to SI1 plus SI2. It is equal to 3,960 plus 4,554, which is 8,514. Therefore, the compound interest is equal to Rs 8,514, or amount minus principal, which is equal to 34,914 minus 26,400. That is equal to 8,514. Observe that, if there is a need to calculate compound interest for 11 years, the above procedure becomes very long. Let us find out an easier way to find compound interest. Compound interest. Part 3. Deducing a formula for compound interest. Consider the previous example that we worked on earlier. P1 is equal to 26,400. R1 equals to 15. t equals to 1. Therefore, SI1 is equal to 26,400 into 15 into 1 by 100. A1 is equal to 26,400 plus 26,400 into 15 into 1 by 100, which is equal to 26,400 into 1 plus 15 by 100. That is equal to P2. Or, we can say that SI1 is equal to P into R into 1 by 100. Or, A1 is equal to P1 plus SI1, which is equal to P1 plus P1R1 by 100, which is equal to P1 into 1 plus R by 100. That is equal to P2. SI2 is equal to 26,400 into 1 plus 15 by 100 into 15 into 1 by 100. It is equal to 26,400 into 15 by 100 into 1 plus 15 by 100. It can be observed that SI2 is equal to P2 into R into 1 by 100. It is equal to P1 into 1 plus R by 100 into R by 100, which is equal to P1R by 100 into 1 plus R by 100. A2 is equal to 26,400 into 1 plus 15 by 100 plus 26,400 into 15 by 100 into 1 plus 15 by 100. That is, A2 is equal to P2 plus SI2, which is equal to P1 into 1 plus R by 100 plus P1R by 100 into 1 plus R by 100. So, A2 is equal to 26,400 into 1 plus 15 by 100 into 1 plus 15 by 100. That is, P1 into 1 plus R by 100 into 1 plus R by 100. It is equal to 26,400 into 1 plus 15 by 100 whole square, which is equal to P3. That is, P1 is equal to 1 plus R by 100 whole square, which is equal to P3. Proceeding in this way, the amount, at the end of n years will be AN is equal to P into 1 plus R by 100, whole power n. Compound interest is equal to AN minus P. Hence, we have deduced a formula for compound interest. Rate compounded annually, or half-yearly. Rate compounded annually. We say that the rate is compounded annually when the interest is charged at the end of every year. Here, the rate is given for 1 year. Whereas, when we say that the rate is compounded half-yearly, the rate is half of that of 1 year, with a time period of 2 half-years. Here, the interest is charged twice a year. Given rate compounded annually. P is equal to rupees 200 at 10% per annum, compounded annually. T is equal to 1 year. I is equal to 200 into 10 into 1 by 100, which is equal to rupees 20. Amount A is equal to rupees 200 plus rupees 20, that is rupees 220. Rate compounded half yearly. P is equal to rupees 200, at a rate of 10% per annum, compounded half yearly. Time period is 6 months, or half year. I is equal to 200 into 10 into 1 by 2. Whole divided by 100, which is equal to rupees 10. Amount A is equal to 200 plus 10, which is equal to rupees 210. For the next 6 months, P is equal to 210. So, I is equal to 210 into 10 into half, whole divided by 100, which is equal to rupees 10.5. A is equal to rupees 210 plus 10.5, which is equal to rupees 220.5. Problem. REF took a loan of rupees 80,000 from a bank. If the rate of interest is 10% per annum, find the difference in amounts he would be paying after 1.5 years. If the interest is compounded annually, or compounded half yearly. Solution. If the interest is compounded annually, and the amount paid after 1.5 years. Given. Principal, P, is equal to rupees 80,000. Rate of interest, R, is equal to 10% per annum. N, is equal to 1 year. Therefore, A is equal to, P into 1, plus, R, by 100, whole to the power, N. It can be calculated to be rupees 88,000. Now, we need to calculate the simple interest on rupees 88,000, at 10% per annum, for half a year. Simple interest is equal to 88,000 into 10 into 1 by 2, divided by 100. It is equal to rupees 4,400. Therefore, the required amount to be paid, if interest is compounded annually, is equal to rupees 88,000 plus rupees 4,400, which is equal to 92,400. Let us look at the same, when the interest is compounded half yearly. Principal is equal to rupees 80,000. Rate is equal to 10% per annum, compounded half yearly, which is equal to 10 by 2% for half a year, which is equal to 5% per half year. N is equal to 3 half years. A is equal to P into 1 plus R by 100 whole to the power N. It can be calculated as rupees 92,610. This is the required amount to be paid if the interest is compounded half yearly. The difference in amounts is equal to rupees 92,610 minus 92,400. That is, the difference in amounts is rupees 210. Application of compound interest formula. Some of the applications of the compound interest formula are to find increase, decrease in population, the growth of bacteria, if the rate of growth is known, the value of an item, if it increases or decreases in intermediate years. Here, decrease represents depreciation. Depreciation is defined as a reduction of value due to use and age of an item. Then, the amount can be calculated as AN is equal to P into 1 minus R by 100, whole power N. Example: a motorbike was bought at rupees 42,000. Its value is depreciated at a rate of 8% per annum. Find its value after 1 year. Solution: given P is equal to rupees 42,000, R is equal to 8% per annum, N is equal to 1 year. As we know, A is equal to P into 1 minus R by 100, whole power N. By substituting the respective values and simplifying, we get A is equal to rupees 38,640. Therefore, its value after 1 year is rupees 38,640.